Okay, so today I wanted to find out if I could communicate with an Arduino using the 3.5mm jack on my phone. First I grabbed an old server that I had laying around and I connected it to the Arduino on digital pin 9. Then I took a 3.5mm jack adapter and connected one end to my phone and the other to an Arduino on analog pin 0. I printed the values that Arduino was reading from the audio jack, and I noticed that by changing the volume, the values also changed. They ranged from 0 to about 200. I took advantage of this by programming the Arduino such that each of these values would correspond to the angle that the server turned. If I put the volume at 0, the server would be at 0 degrees. If I put the volume at 100, the server would be at 180 degrees or thereabout. This is a simple, not very accurate example of how you can control a device over your phone. So playing with servers is fun, but what about data transfer? I wanted to try if I could send text over audio jack. Since the signal produced by the phone is AC, I needed a way to encode data inside it and then decode it back on Arduino. I watched a great video by Wireless Explained, who explained that encoding data into electromagnetic waves is called modulation, and that there are many ways to do it. I decided to go with FSK, frequency shift keying modulation, because the AI suggested it. In FSK modulation, we change the frequency of the signal to embed ones and zeros into the signal. For example, if you want to send a 1 and a 0 over the wire, we can play a high frequency sound for a second and then a low frequency sound for a second. The high frequency represents a 1 and the low frequency a 0. To embed this data, I wrote a short Python notebook that takes a message, for example the word hello, transforms it into ones and zeros, and creates an audio file based on these values. In the code, I first defined the parameters for the audio I wanted to generate. Then I made a generate tone function, which generates a sine wave at the provided frequency and duration. Then we have an encode string function, which takes in a string, that is a sequence of characters, and then for each character it generates a start bit, which is a 1, gets the corresponding binary code for that character. For example, H is 011010000, generates a tone for each of those ones and zeros, generates a stop bit, which is a 0, adds a bit more silence at the end, and then adds it all together in an array. Then after we have all the individual sounds, we save them together in a WAV file, which we can play on the smartphone. I opened the generated WAV file in Audacity, and if we zoom in a bit, we can actually see the individual bits. The file starts with 50 milliseconds of silence, followed by a 1, 0, 1, 0, 0, and so on. And this is what it sounds like. To decode this file on the Arduino, I first made a DC offset circuit that raises the signal produced by the phone by about 2.5 volts. This is because the Arduino ADC converter can only read voltages between 0 and 5 volts, while the phone produces voltage between +1 and -9 volts. So with this circuit we get values between 1.5 and 3.5 volts. Then I wrote the Arduino code, which basically checks how many times the sine wave crosses the center line in a given amount of time, which gives us the frequency. If the frequency is above a certain threshold, that's a 1, and if it's below, it's a 0. It does this for each individual byte and then returns the corresponding character. And when I run this program and play the generated sound over my phone, we get the word hello printed in the console. That's it for now. Thank you for watching, and I'll see you next time.